In this experiment, we will study the effect of substrate concentration on the enzymatic activity of alpha-amylase. Now, enzymes, these are the biocatalysts that speed up the rate of reaction without itself being involved in the reaction. Also, these enzymes, the reactants of the enzyme catalyzed reactions are called as substrates. And every enzyme is quite specific with respect to its substrate, and it reacts with a specific substrate to give a particular product. Now, the enzymatic activity, it depends on many factors like pH, like temperature, like the concentration of the enzymes and the substrate concentration. Now, in this experiment, we will study the effect of substrate concentration on the enzymatic activity of alpha-amylase. Now, this enzyme, it is particularly needed in the germinating seeds, especially when there is requirement of glucose. Hence, it mobilizes starch to the seed. Now, let's start preparing the chemicals. First, we have to prepare 1% starch solution. For this, we will dissolve 0.5 gram of starch in 50 ml of distilled water, and by this we will get 1% starch solution. Then we have to prepare a phosphate buffer. For this, we need stock solution A and stock solution B. For stock solution A, we need dipotassium phosphate, and we will dissolve it in 100 ml of distilled water, and we will take 7.1 gram of dipotassium phosphate in 100 ml of water. And for stock solution B, we will take monopotassium phosphate, and we will dissolve 1.1 gram of monopotassium phosphate in 100 ml of distilled water. Then we will take 84 ml of stock solution A in this flask and 16 ml of stock solution B in this flask. By this, we will get 100 ml of phosphate buffer in with pH 7. Now the phosphate buffer is ready. Now as the chemicals are ready, let's start the experiment. First, we soak these barley seeds overnight. After this, we grind these seeds to release the enzyme and the other components. After this, the filtrate obtained is filtered, and the content is then collected in a beaker. After this, we will take 5 different test tubes and follow the procedure. Like in the test tube, there is test tube 1, 2, 3, 4 and 5. In these test tubes, we will add 1 ml of substrate, starch concentration is this 2 ml, 3, 4 and 5. That is increasing order of substrate concentration in these test tubes. Obviously, then there will be 4, 3, 2, 1 and 0 ml of phosphate buffer in this, so that the total volume is 5 ml in all of these test tubes. After that, we will add 1 iodine drop in all of them, followed by the enzyme extract, that is this. It has been already added in this. Also, the enzyme extract, it will be added 1 ml each in all of these test tubes. Now we will add iodine drop in each of these test tubes. Now the time taken, the iodine will react with the starch. The starch, then it will decolorize, because the alpha amylase, it will convert the starch present into the simpler carbohydrates. Now the time taken by the by this to decolorize, that is from blue, blue color will disappear. It will denote the time taken for starch to break down, and that will denote the rate of enzymatic reaction, and by that we will plot a graph. Now, as I mentioned, these are the 5 test tubes with increasing concentration of substrate. That is, in test tube number 1, we have 1 ml of substrate, in 2 ml of substrate, and in 5th test tube, we have the 5 ml of substrate. So, the substrate concentration is increasing. Now, in each of the test tube, we will add enzyme extract, approximately 1 ml of enzyme extract in each of the test tube. After this, we will add the iodine to note the time taken to decolorize, that is the time taken for the starch to break down. That will give us the rate of enzymatic reaction, that is the rate of starch breakdown. Now, first we will add the iodine. Now the appearance of color has been seen, and the time taken for this to decolorize will be noted. Similarly, in all of the test tubes, the same will be repeated. Now, if I see in the test tube number 5, that is here the substrate concentration is maximum. Now, upon adding the iodine solution, we will note the time taken to decolorize. As you can see, the time we can see the appearance of more darker color in this one, and if we note the time taken to decolorize, the test tube 5 will have less amount of time to decolorize as compared to the test tube 1, and other test tubes will have intermediate times. The time will be noted on the table. So this table depicts the effect of different substrate concentrations on the alpha amylase activity. As you can see, the calculations are given approximate measures of everything that we put on this in each of the test tube. So this is the time taken for the decolorization, that is in test tube 1 around 37 seconds, then 28, 20, 15, and then 15. So if we calculate 1 divided by the time taken, this will give us the rate of enzymatic reaction. Now we will plot this on a graph, where on x-axis it shows the substrate concentration, and on y-axis it is the rate of enzymatic reaction. As we can see that with increase in the substrate concentration, the rate of enzymatic reaction increases, but only up to a certain level. After then, the substrate concentration increase in the substrate concentration, it has no effect on the rate of enzymatic reaction. So this is because the active sites present in the enzymes are all occupied by the substrate. Now after adding now if we add more substrate, the active sites are all occupied, there are no free active sites. So therefore, after a certain point of time, the increase in substrate concentration does not help in increasing the rate of enzymatic reaction.